When I was growing up, it was thought intrinsically unfeminine to do mathematics. People made eyes at me anyway because I was called Dusa after Medusa, and they said, well, you can't turn us to stone. You couldn't be a woman and do mathematics. You know, I'd always had a great split in between sort of being a female and being a mathematician. I sort of was leading two lives for a long, long time. So it was very important at some point to begin to integrate that. One thing that I think that holds women back is their own expectations of what they should do, as well as what they think other people think they should do. When I met Gelfand, he showed me what mathematical intuition was. He had a completely different view of mathematics. It was really what I dreamt of. I mean, this was the first place I'd been where I thought mathematics was as I thought it should be.
If you had to choose a main results that you prove in your life, what would you choose?
I think the thing I wrote on rational and ruled manifolds, it introduced symplectic geometry to topologists. I think it was one of the first papers that made people like Donaldson or Taubes think that symplectic geometry really had something to say about four-dimensional things. I would say it's an essential component of the geometry that's related to physics. I mean, obviously Riemannian geometry is related to curvature and space-time relativity, but I think that symplectic geometry is right in there with energy-conserving flows. I mean, it's another essential ingredient. Of course, these days, it does have a very important role to play in string theory and these strange dualities and mirror symmetry and things which relate it to algebraic geometry on the other side. That's very fascinating. I think it's one of the core geometries.